Hi guys, this is question number 2 in your Collision 2 homework packet. So we have a car that is going to the right with 12 meters per second, that is 1,000 kilogram, and it's hitting to an object that we don't know the mass of, and it's stationary. And after they hit, they stick together and they move together. And their velocity after the collision is not constant, it's basically a function. So that function is basically telling us its velocity with respect to time. So in part A, they are asking for the mass of this unknown mass. So to be able to figure out, well, first thing that comes to mind is conservation of momentum, because we have two objects, they're going to stick together, so that's in perfectly inelastic collision. So we can get somewhere from there. But once we write it down, m1 v1 initial plus m2 v2 initial equals m1 plus m2 times v final. So in the first part we don't have any problem. 1,000 times 12 plus 0, because this is stationary, even if you don't know the mass of it, since it's stationary it's not going to have any momentum, so that's cancelled. So we don't have any problem over here. And in the second part, after the collision, this guy is still 1,000, but we do not know the mass of the second object. And we also don't know the final velocity. So we have two unknown, but we have one equation. So mathematically, we cannot solve those two. So since we are trying to figure out this m, we should know that v final, technically. And we actually can figure this final velocity out because, so if you think about this, this is a function of those two objects after they collide, and that is giving us the velocity of those two objects at any time that we want. And since this v final is right after the collision, then if you place a 0 for that time, because that is going to represent my moment to start motion after the collision. So if I put 0 for this time, then this is going to give me, this function will give me the final velocity of that object. So then let's do this. V place 0, 8, 1, 5 times 0. So 8, 1 plus 0 is 1, so 8 divided by 1 is going to be 8 meters per second. So now all we need to do is plug in this 8 for this v final, then we're going to be able to solve this for mass. So on this left side we have 12,000, and on the right side we have 1,000 plus m times 8. So since we're trying to figure this m out, we need to get rid of this 8 first, so divide both sides by 8. Then 1,500 is going to be equal to 1,000 plus m, and your m will become 500 kg. So this is part A. And in part B, they are asking for position of this object with respect to time. So they are basically asking for x as a function of time. And if you look at your first chapter notes in the kinematics, the relationship between position and velocity, because we have velocity function and we are trying to go to the position. So if you look at it, if you go from velocity to position, then you should have seen that it is the integral of that v function. Velocity is a function of time, dt. So that is going to give us basically the position of this object as a function of time. So then let's plug in and let's see what's happening. It's 8 divided by 1 plus 5t dt. And another important thing over here, we need to define our borders. So what is my initial time and what is my final time? So if you think about it, this, and the question already says that this is going to start with 0 time, because this is a function of this motion right after they collide, and they put the time as 0 for that time. And then we are trying to figure out position of this object at any time t, all right, because we are trying to find a general function. So then we are not going to go to a certain number, we are going to go to a time t that we call, all right, any time t. So that is going to basically give us another function. Now, how are we going to be able to solve this integral? So if you look at it, you have a number on the top, you have a function in the bottom. So that is not an easy integral for us to solve. Then what should we do? We should use u-v transformation. So we are going to call this bottom part because that's where it has what has the t function, and I'm trying to get the derivative of that, integral of that. So we are calling this 1 plus 5t a function u. Then what are we trying to figure out? We are going to replace this with u, but then we are going to have dt right here. But we cannot get the derivative of this function with respect to time, because we are going to call it u. Then what should we do? We need to replace this guy with du. So to be able to figure out the relationship in between du and dt, we basically take the derivative of this guy with respect to time. So du over dt will become what? Du over dt, which means this is my u function. Take the derivative of this with respect to time. So if you take the derivative of 1 with respect to t, you get 0, so you have nothing. And if you take the derivative of 5t with respect to t, then that is going to give you 5. Then, what is the relationship in between dt and du? The ratio of du over dt is 5. But what am I trying to figure out? I'm trying to get rid of this dt. So isolate this dt and see what do you have. So if you would like to isolate this dt right here, you can just switch them, and that is going to give you the relationship in between du and dt. So wherever you see dt, you can put du over 5. So 1 plus 5t is my u, and my dt will be du over 5. So now let's replace them and see what we have. So x as a function of time equals from 0 to t, 8 over u times, instead of dt, I will put du over 5. And now this is an integral that I can take right now. So you have 8 on the top, 5 in the bottom, and that's a multiplication. So that means I can take those out of the integral. Then my integral will look like 8 over 5, 0 to t anytime t, du over u. Again, that's a special integral right now. 1 over u, or 1 over any function, would be ln function, or the integral of 1 over u will be ln. Then my xt will become, so I can integrate that right now. 8 over 5 is outside of the integral, and my integral will be taken as ln u. But at this point, once you take the integral out, like once you get the integral of it, then you can replace this u back to wherever it was before. So then I will just make it 1 plus 5t, and then my boundaries are 0. Let's make this a little bit closer. 0, and t. And that is going to be my integral. So now what should I do? I should take the integral of, or I should replace the upper and lower boundaries and then finalize the integral. So xt is 8/5 times. So the rule for placing upper and lower boundaries is basically replace your variable. My variable in this equation is t. Replace this variable with the upper boundary, so in this case they are the same, and you replace this variable with the lower boundary, and then get the difference. So ln 1 plus 5. So I'm going to replace my variable with the upper boundary. So in this case, they are the same because the variable t is t, and then we are also trying to set this equation as a function of time. So we are basically using the same thing for two different things. So it seems kind of weird, but that's how it is. So you close the parenthesis, so you put the upper boundary for the function, then minus, then you're going to put the lower boundary now. So ln 1 plus 5, you replace your variable with the lower boundary, 0, and then you close the parenthesis. And again, in the ln function, you should remember if you have ln something minus ln something, then you can put those two together as a division. So x as a function of time equals 8/5, and that is going to be equal to, so if you just do the equation over here, 5 times 0 is just 0, then 0 plus 1 is just 1. So on this part, you only have ln 1. Again, ln 1 plus 5t minus ln 1, you can write this one down as a division, first one divided by the second one. So on the top you have 1 plus 5t, and the bottom you have just 1. Then this is basically your function. And if you divide anything by 1, this is just itself. Then my function, my position function with respect to time is 8/5 ln 1 plus 5t. So this is my position as a function of time. In part C, they're asking for the resisting force. So since this guy, as time goes on, this guy is going to get less and less. So that means it's slowing down, so that means there's a force. And what is the function of that force with respect to time? So then you just write down F equals ma. And remember, acceleration can be written as dv over dt. So then my equation will become m dv over dt. Then my v function, I know my v function, then my equation will become m, my dv, and my v function is 8 divided by 1 plus 5t divided by dt. So now we just need to take the derivative of this function with respect to time. So now here I should also remind another thing, because this derivation, I showed it in the class, but it was at the end, so probably, or you might not have that as a note. So that's a division. So it's a number divided by another number. So if you're trying to take the derivative of that function, then this derivative is a little bit different. So derivative of, let's say you have an f of x, f as a function of x, then let's say you have a divided by b. And you are trying to take the derivative of this function, all right? You are trying to take the derivative of f of x. So remember, this is that means you're taking the derivative of that function. And again, if it's a over b, the way that you take the derivative of this guy is derivative of numerator times denominator minus numerator times derivative of the denominator divided by square of the denominator. Alright, this is basically how you take the derivative of a division function. So this is a rule. So if you don't have it in your notes, put that in your notes. Now, let's move to our question. We have basically 8 as A and 1 plus 5t as B. So we're going to apply this rule. And we also have M over here. So which mass is this? So if you think about it, this function, this velocity function, is after they collide, which means we are talking about those two objects moving together. So my M over here is also a number, and it is going to be the sum of the masses. So 1,000 plus 500. So we're going to have that one as our mass. So now let's plug in the numbers. F equals 1,500 times. So let's take the derivative of this guy. So derivative of 8 time denominator 1 plus 5t minus derivative of the denominator, or we first multiply it with a, which is numerator. So 8 times derivative of the denominator. So derivative of 1 plus 5t derivative. Hopefully it's not blocking. And in the bottom, what do you have? Square of denominator. So 1 plus 5t square. Then let's do the math right here. 1,500, that's outside, times. So derivative of 8 with respect to time, because all of those derivatives are with respect to time. So that you have no time function here, so derivative of a constant is going to be 0. So if this is 0, 0 times any number will be 0. So you are going to have 0 minus. Then what will be the derivative of this guy? You have 8 outside times derivative of 1 plus 5t. So derivative of 1 is 0 again, and derivative of 5t with respect to time is going to be just the coefficient, so it's just 5. And divided by, well, if you want, you can also take the square of this, but on the solution manual, they also accepted this as 1 plus 5t squared, so you can just leave it that way. Then, my force as a function of time will become what? So 0 minus 8 times 5. 8 times 5 is 40. So that's 0 minus 40. So the top part will become negative 40. And negative 40 times 1,500 is going to negative 60,000. I think I got it right. Divided by 1 plus 5t squared. So this is my force as a function of time. And the reason that you have negative over here is velocity is going in one direction, but since it's slowing down, force is acting on it in a negative direction, in the opposite direction of the velocity. So that's why we found it as negative. And in part D, they are asking for an impulse for certain time periods. So what's your impulse from t equals 0 to t equals 2 seconds? So to be able to figure this out, we need to remember the meaning of impulse. Remember, impulse is change in momentum, or it is mass times delta V, right? So we know the mass of the object, we just need delta V. So what is the change in velocity? And to be able to figure this out, we are again going to use this function because that tells us velocity is a function of time. So whatever time that we need, we just plug it in, and that's going to tell us the velocity at that certain time. Then what are we going to do? We will just plug in 0 and 2 for that t in this function, and that's going to give us the velocity, and then we will just plug in those numbers over here. So let's find the numbers first. Well, we have v as a 0. I mean, once we have time 0, we figure that out. Over here, it's already 8, but let's do that again. v0 equals 8 divided by 1 plus 5 times 0. So that's 8 meters per second. So that's my velocity when time is 0. And when time is 2, then my new velocity will be 8 divided by 1 plus 5 times 2. And if you do the math over here, what do you get? 8 divided by 1 plus 5 times 2, which is 10. 10 plus 1, 11. So it's 8 divided by 11 meters per second. So now, what should we do? We just need to replace those numbers into that equation. So my J will become mass. Alright, again, which mass are we talking about? We are talking about those guys moving after they collide. So we are talking about the total mass of the system. So it's 1500 times find delta V, which is V final. Let me write this one down over here as explicit. So V final minus V initial. So this is my final time, which is 8 divided by 11 minus 8, and that is going to be basically my equation. And once you solve this, what are you going to find J, or impulse, as? Again, negative 10,910 newtons second. So this is going to be the impulse from time 0 seconds to 2 seconds. Alright, so this is your solution for your second question on your Collision 2 homework paper.